Tonight we're on the study of the helium method, another age-dating method. We're concluding that. We're at Bible Study Manuals, K61.htm. Let's click on that and look for studies of the helium method. Dr. Patton concludes, studies of the helium method have shown that low ages based on helium obtained on common rock-forming minerals do not necessarily reflect diffusive loss of helium from the lattices of those minerals. Under ideal conditions, some mineral lattices even appear to retain helium quantitatively for longer than 108 years. So these presumptions that evolutionists make about how much helium would have been released over 5 billion years just doesn't materialize. There's so little on the Earth. So they say it all escaped into outer space. Maybe aliens came and just sucked it up from the atmosphere. Anyway, helium-3. Prior to the flood, it is probable that the ratio of ordinary carbon to radiocarbon in the atmosphere was much higher than at present, mainly because of the global semi-tropical climate and the vast amounts of plant life found around this world. This effect would have been augmented by the smaller amount of carbon sustained in the ocean than now, since the oceans were smaller and the land areas larger before the flood. And it is possible that it would still be further augmented by the shielding effect of the thermal canopy, which would have inhibited the formations of radiocarbon in the high atmosphere. All of these factors would have reduced the ratio of radiocarbon to ordinary carbon to a much smaller fraction than now obtains. Another possible effect of the canopy, which is the ice canopy, the water ice canopy over the Earth before the flood, is very interesting. In addition to the formation of carbon-14 from nitrogen in the atmosphere by cosmic ray neutrons, these neutrons also react with deuterium, heavy hydrogen, the hydrogen isotope in heavy water, which would undoubtedly have been present in substantial amounts in such a canopy to form tritium, a still heavier isotope of hydrogen. Tritium is unstable and decays rapidly by beta decay to an isotope of helium, helium-3, but it still turns out there is too much helium-3 in the atmosphere to be accounted for by this process operating at present rates during geologic time. The Cosmic Ray Authority, CORF, suggests the following solution of the problem. He says there are two factors which would tend to increase the amount of tritium. One of these is that the intensity of cosmic radiation, and hence the rate of production of neutrons, might have been higher at some time in the geologic past. The second possibility invoking action in the past assumes that at a time when the Earth was warmer, the atmosphere contained much more water vapor, and the process of generating tritium from deuterium might have been operating at a much higher rate than at present. That's Sergei Korf, Effects of the Cosmic Radiation on Terrestrial Isotope Distribution. The canopy, thus, not only provides an explanation for the present excess of atmospheric helium-3, that's the canopy that resulted in the worldwide flood when it was collapsing over the Earth, but it also implies that the proportion of cosmic ray neutrons reacting with nitrogen to form radiocarbon would be smaller by the amount reacting thus with the hydrogen. This factor combines with others mentioned to assure that the percent of radiocarbon in the carbon dioxide of the antediluvian, the pre-flood atmosphere, must have been much smaller than at present. Therefore, the radioactivity of living organisms ingesting this carbon dioxide would have been much smaller than that of organisms living at present. So, young Earth. We look at the low salt content of the sea indicates a recent creation. Still another evidence of terrestrial youth is found in geochemical analyses of ocean waters. The salts and other chemicals in the sea are being continually augmented through the process of land inundation and river transportation of the materials of erosion to the sea. Under the assumption that the ocean originally contained none of a specific element and that the rate of supply has always been the same as at present, neither assumption of course valid, it is possible to obtain a maximum age for the ocean and therefore presumably of the Earth, on the basis of the measured quantities and rates existing today. That's what the evolutionists are looking for, to find something that supports their belief system. The most common chemicals in ocean are, of course, sodium and chlorine. The constituents of ordinary table salts, sodium and chlorine, the constituents sodium averages 10.8 and chlorine 19.6 parts per thousand in ocean water on the average. Now, Pierce and Gunter, in their study on salinity, in average river water, these proportions are only 0.0085 and 0.0083 parts per thousand, respectively. Oceans constitute about 315 million cubic miles of water volume, and rivers about 50,000 cubic miles. And of the latter, about 8,200 cubic miles annually run off to the seas and are replenished by rainfall. The maximum age of the ocean, as determined from its sodium content, is thus computed at this formula here. That's about 50 million years, they say. And the corresponding chlorine calculation yields about 90 million years. Obviously, both are vastly less. Excuse me, I scratch my eye with my spoon so I don't touch my face. Okay, it's about, let's see, the average, both are less, the corresponding chlorine counts 90 million. Both are obviously vastly less than the 5 billion years. Attempts to make direct estimates of the age of the ocean on the basis of its salt content meet with difficulty. Those based on the amount of sodium in the sea and present rate of erosion put the age at only about 50 million years, a figure that was once accepted as the age of the Earth. Thus, this figure is only a fraction of that now attributed to the oldest sedimentary rocks. Maybe they came before the Earth came, right? The formation of which depended upon the existence of oceans and continents. Well, the rocks came before the Earth surrounded itself on it? Well, no, I don't think so. The usual way, Blum says, of attempting to sidestep this difficulty is to assume a large amount of cyclic sodium, etc., material that has somehow been precipitated on the lands and re-eroded and retransported, perhaps several times. Of such cyclic sodium there is no definite measure, but even the most generous estimates are inadequate to explain the profound discrepancies of billions of years. However, it's not thought that the total salt which has been carried into the oceans and has remained there, been cyclic and is in rock salt and salt water in the strata can and alter the estimate to much more than 200 million years. We're still short of 5 billion, aren't we? This appears to be, Fox says, the maximum figure that can be possible to be allowed for the age of the ocean on the basis of its most important chemical constituent, salt. But it should be obvious that this is impossibly high because it involves the absurd assumption that the ocean contained no sodium to begin with. Wow, yeah. Modern marine biologists and oceanographers are, on the other hand, convinced that the salinity of the ocean has always been about as it is now. Other chemicals in the ocean give even shorter age estimates when calculated on a similar basis. See for a more extended discussion of this subject, the booklet by D.J. Whitney, How Old is the Earth? Also by the same author, The Face of the Deep. It seems reasonably certain that the salinity of the ocean has remained both quantitatively and qualitatively constant within quite narrow limits since the Cambrian. That's the lowest rock strata where life is. Indeed, there is no reason to doubt that the oceans as great basins of salt water were already present in Precambrian times. The net result of these considerations would seem to be, quite plainly, that the oceans of the world must be extremely youthful. Both paleobiological and geochemical considerations seem to require that the ocean has always been nearly as saline as at present, but that it is continuously becoming more saline year by year. This process cannot be going on for very long. In connection with the salinity of the ocean, a supposed difficulty with the deluge record has been imagined by some writers who say that the mixing of salt and fresh waters in a universal flood would have been fatal to marine creatures accustomed to saline waters and to lacustrine and river fish used to fresh waters. That multitudes of water inhabitants were killed in the deluge is certain, but there is no reason to suppose the change to have been sudden enough or sharp enough to prevent adaptation of at least some individuals species out of each group to their altered environment. The change at the deluge would, for some at least, would be to decrease the salinity of most waters, and as Black points out in Gunter 1942, found that for every freshwater fish that has been taken in seawater in North America, no species of marine fish have been taken in freshwater. It seems to be easier for fishes to adapt themselves to excess water than to excess salt. So we have an interesting note in Science. Describes sharks and sawfish, both marine creatures, found in a freshwater mountain lake, miles inland and 500 feet above sea level in western Dutch New Guinea. All fish must be adaptable to at least a certain range of salinities, so it is not unreasonable that some individuals of each kind would be able to survive the gradual mixing of the waters and gradual change in salinities during and after the flood. Very often you find species from both fresh and seawater in the areas where a river tributary goes into the ocean, and they graduate into a more saline situation or less, and still survive and don't die. They're adaptable. The small amount of juvenile original volcanic water indicates a young Earth. So we have, as a matter of fact, there is some basis for believing that the water of the ocean has itself come out of the Earth by volcanic emanations in the form of steam, and that this process as well cannot have continued for a period as long as the supposed age of the lithosphere. It is not ordinarily appreciated with tremendous amounts of juvenile water, that is, water reaching the surface of the Earth for the first time or poured out on this Earth's surface every time a volcano erupts. It is hard to obtain accurate data, of course. Probably the best are those that were obtained on the famous Mexican volcano Pt92 during the period 1943 to 52 of its most active life. If the proportion of water to total solids had been nearly constant throughout the period of activity of the volcano, the total weight of water expelled would have amounted to some 39 million metric tons, the approximate weight of a body of water about 6 kilometers square by 1 meter deep. So Fries says, the U.S. Geological Survey personnel making these measurements and studies of Pt92 were of the opinion that all of this water is truly juvenile water, although there are various theories. Most volcanologists now believe that this to be true of at least most and probably all of the water expelled from volcanoes. Until the turn of the present century, many geologists considered lava to get its water by seepage from ocean bottoms. Now generally discarded, this view has been replaced by a startling proposal. Volcanic water, say numerous analysts, comes from primary constituents, that is, the original water from which the planet was formed. Gary Webster says, the Pt92 water described above can be computed as, on the average, about 1/1000th of a cubic mile per year. In view of the fact that there are some 400 to 500 active volcanoes on the continents of the world, with several times that number known to have been active in the recent geologic past, we feel it is not unreasonable to guess that the average annual activity of volcanoes in the world has been such as to produce at least 1 cubic mile of juvenile water each year. Probably this is a gross underestimate in view of the tremendous amounts of igneous rocks on and near the first surface of the Earth, which, whatever their method of formation may have been, were certainly accompanied by the expulsion of tremendous amounts of entrapped waters. It is also known that there are many acute active volcanoes on the ocean bottom, and there have been many more in the past. Obviously, the number of production of these is almost entirely unknown, but both must be very great. In view of all these factors, we feel that a figure of 1 cubic mile of water per year on the average throughout geologic time is a bare minimum estimate of the increment of water added to the oceans. Since the ocean now contains approximately 315 million cubic miles of water, about 340 million cubic miles if all the water of the Earth's crust and atmosphere, rivers, lakes is added, a simple calculation will yield a figure of 315 to 340 million years as the maximum possible age of the Earth, even on the assumption that all the water in the ocean has originated through volcanic action. Once again, this is far less than the 4 to 5 billion years. We're being very conservative and showing that we can't even get to 1 billion years. And of course, all of this completely ignores the revelation of the initial condition of the created Earth in Genesis 1:2, which described it as covered with water. Furthermore, it ignores the account of the deluge when great volumes of juvenile water were caused to